Hi everyone, welcome to my home and the lab where we're going to do some science. So Dr. Christensen gets to do all the cool stuff for this course. He gets to do the labs, he gets to show you what goes on in the lab, generate data, analyze it, and I don't. But today I get even because we're going to do some science. But we're going to do the science on a bike, and the science is going to be about energy conserving fields. So it may sound very theoretical, but it actually has a very practical consequence in the sense that, as you've learned, when we change our altitude, we change the amount of potential energy that we gain. And so the total energy we expend to gain that potential energy should be the same. So if we take that lesson to the extreme, then you can see that if we start from one altitude and end up at another altitude, that it really shouldn't matter how we get there. The energy we expend should be the same. So today we're going to examine that question based on some real data. So what kind of data? Well, for the data, I need the proper eyewear. So for the data, I get to ride a bike. And I get to ride two routes, not too far from where I live, that both start at the same place and then both end at the same place, and they gain some altitude in between. And I'll give you the details of this a little later on. But the point is that they should, according to conservation of energy, be the same in the sense that it should take me the same amount of energy or maybe the same amount of time or something similar, because at the end of the day, I'll have gained the same amount of potential energy, independent of the path that I take. Now the question is that real? And are there other factors involved? And that's really our task today, is to figure out what other factors might be involved. And then more generally, I want to use this exercise to help you think about how you design experiments. So how would you do this experiment? How would you evaluate this conservation law? And it's a law, right? So it's got to be serious. How would you evaluate this conservation law if you're going to do this experiment? And I'll go through some of the details in a bit of how I did it. You can see there's a route. In fact, I'll show you the route right now. So you can see there's the two routes marked on this map. And from that map, you can see they start at the same place, they end at the same place. You can see the altitude difference. You can also see the difference in duration in terms of distance of those two routes. And now all we have to do is ride up and down them, or up them more importantly, a few times, and see how long it takes for me to go one route versus the other route. Now I've been doing this experiment all summer long. I'm going to show you way more data than I could collect in a single day without getting seriously tired. So we're going to go through the data that I collected, and we're going to try and anticipate, based on the route first of all, which way we think will take longer, for example, or which way will take more energy or more power on my part. I'm going to give you approximate power numbers. I don't have a power meter on the bike, but this software called Strava that I use to record all these things will give me an estimate for that power. And we can use that as a good enough estimate because we've used the same method in both routes, so it's probably accurate enough for our purposes. And then we're going to see what the data tell us. And I want you to think beforehand, based on the route and the route profile and the distance differences, what do you think will happen? So give this some thought in the meantime, and I'm going to go out and ride my bike. So we'll see you in a little bit once I have a little more data to share with you. In the meantime, start thinking about which way do you think will take me longer. Bye.